Hello guys, and welcome back to another episode of chemistry. And today we are going to be looking at we're going to continue our study actually on aldehydes and ketones. But specifically today we're going to see how aldehydes or the alkanals are prepared. Okay, so please let's look at that. Preparation of aldehydes. So it's either you call them the aldehydes or you call them the alkanals. Please do not forget, okay? They're also called the alkanals. Okay, so just do not forget also that this tutorial is brought to you by the O3 School JAMB Practice app. It is all you need to succeed in your exam. I've said it before and I'll keep saying it, all right? Please let your friends know, let your enemies know. Let them know, your classmates, let them know, everybody that you know that, okay, that was writing JAMB, let that person know, okay, the person needs this application on his or her device. Before we talk about the app, let us see a question from the app about alkanals preparation. This is a 2022 question number 37. 2022 number 37. It has been displayed on the screen right now. It says, alkanals can be prepared by oxidizing primary alkanols using, okay, A says acidified potassium. B says acidified calcium magnesium oxide. C says acidified KMnO4. D says acidified KClMnO4. Okay, so we'll get to this question and many more from this application at the end of the class, because in O3 schools we believe in giving you value first. Let us teach you. Once we teach you, then answering questions will become a very easy thing to do. All right, so passing your exam also will be easy. So please, we are doing chemistry episode from the beginning of chemistry, the first topic on your syllabus up to now. Okay, so that means you have everything you need as a chemistry student to succeed in this channel. All right, so please get the application. The app has all the past questions you need, so no need to go and buy past questions outside. As lecture notes structured according to the JAMB syllabus, so no need to be looking for textbook up and down. The Ask Questions has feature where you can search for questions according to topics, and also has the mock challenge. Every Saturday, you conduct a mock challenge on the application. Okay, this mock challenge, not only you that is doing it, all students that are writing JAMB, that are writing JAMB chemistry, okay, are on that application every Saturday. All right, so compete, okay, with your work, with your mates. Get it to JAMB past questions, get it to JAMB likely exam questions, see your score release every Saturday, so you're able to track the progress of your preparation. All right, so please, this app, you need it. Okay, please tell your parents, tell your friends, tell your loved ones, let them get the app. Activation is just for a little fee. Do not tell anybody, to not allow anybody to beg you to activate. Okay, let's go to preparation of aldehydes. Okay, so one of the methods, okay, that we can use to prepare both aldehydes and ketones. In the next episode, we'll actually look at specifically how to prepare ketones, okay? But I'm just giving you a heads up here, because you can prepare aldehydes and ketones by redox. By redox, both of them, you can prepare them by what? By redox, okay? So, oxidation of primary alkanols, okay? Since we're talking about alkanals now, just know that what? Oxidation of primary alkanols, number one. So let me just say from oxidation of primary alkanols or alcohols, the one you call ogogoro. Okay, so oxidation of primary alkanols gives us what? Alkanal. It gives us aldehyde or alkanals. I think we have talked about this before, right? So oxidation of primary alkanols gives us what? Aldehyde. Okay, but the final product of the reaction is supposed to be carboxylic acid. Okay, so the final product of that reaction is supposed to be what? Carboxylic acid. Okay, but what happens is that we use excess alcohol. We use excess alcohol to do this, so that what? The reaction does not what? Proceed to what? Into the formation of what? Of carboxylic acid. Okay, so first of all, primary alkanols, they first get oxidized to what? To aldehydes or alkanals. Okay, and further oxidation now gives us what? Carboxylic acid. Carboxylic what? Acid. Okay, so if you use what? Little quantity of what? Of alcohol, that in the primary alkanols, if you use little quantity of this alkanol, okay, it will first oxidize to what? Aldehydes, and then further oxidize to what? To carboxylic acid. But if you do not want it, okay, to oxidize to carboxylic acid, what you do is that you use excess alcohol. You use what? Excess alcohol. Okay, so that what it will prevent this excess alcohol will prevent the further oxidation of this what alkanal or this aldehyde into carboxylic acid. Okay, so that is one of the first method. That is the first method that we're using what in preparing what aldehydes or what alkanals. Okay, and this is done in the presence of what a very strong oxidizing agent like acidified KMNO4 or what? Or potassium K2CR2O7, potassium what? Dichromate 6. Okay, so these are the oxidizing agents that we use. All right, so primary alkanols are oxidized, okay, into what? Aldehydes or alkanals using what? Acidified potassium permanganate or what? Potassium dichromate 6. These questions are questions that you will see in your exam. So if you do not see KMNO4, you may see K2CR2O7 there. So just know that what you can use any of these two oxidizing agents to what? Oxidize primary alkanol also what? To aldehyde using what? Excess alcohol. Using excess alcohol, you must take note of that. If your aim is to prepare an aldehyde, make sure that you are using what? Excess alcohol. Okay, but if your aim is to prepare what? Carboxylic acid, make sure you reduce the amount of what alcohol. You are not going to use excess alcohol. Okay, so just take note of what? Of all those two. All right, so in the next class, in the next episode, when I'm talking about preparation of ketone, you'll see how what secondary alkanols, okay, are oxidized to what? To alkanones, okay, or what? To the ketones. That will be a method for preparing what do you call it? Alkanones also, okay, or the ketones. So let us see. That's the first method, oxidation of what? Primary alkanol. So what it gives to us is the corresponding what? Aldehyde or alkanal. Let us see. So if you have a primary alkanol like what? C2H5OH, this is what? Ethanol. So this is ethanol, all right? So it is oxidized plus what now? This is how we show what? Oxidizing agent. So in the presence of what now? The oxidizing agent we use there is what? Is acidified. That is KMNO4H2SO4. It is what? It is acidified potassium permanganate. Okay, so it will now give us what now? The corresponding what? Aldehyde. Okay, having the same number of carbon atoms. That will be C, double to O, then what? H. You can complete your structure. H. All right. So this one is our what now? It's our ethanol. All right. So please take note of that. So oxidation of our primary alkanols or primary alcohols gives us what? Aldehydes. Okay, or give us what? Alkanals, as the case may be, if that's what you want to call them. So that is the first method. So the second method is the one we call Rosenmund reduction. Number two, Rosenmund reduction. Number two, Rosenmund reaction. Okay, so this is the second method that we use for preparing what? Aldehydes or alkanals. So please, if you have not liked this video for any reason, what you are doing is very wrong. Okay, we believe we are giving you a lot of value. We believe that you are learning. So please click on the like button, because liking the button will make other students easily find this video. All right, click on the share button. If you are watching from Facebook, click on the share button. On YouTube, click on the share button and share to your WhatsApp group. Okay, even share to your Facebook group. All right, and of course, if it's on TikTok, like and share. If it's on Instagram, like and share. All right, follow us across all social media platforms. All right, and keep learning as you succeed in the exams. So Rosenmund reaction. So this Rosenmund reaction involves the transformation. It involves the transformation of an acyl chloride. Okay, it involves the transformation of an acyl chloride into what? An aldehyde using Linde's what? Catalyst, or in the presence of Linde's catalyst. Take note of that. We say what involves what? The transformation. If you are writing note, transformation of what? Involve transformation of acyl chlorides into aldehydes, into an aldehyde in the presence of what? Linde's catalyst. Okay, this Linde's catalyst is actually what? Palladium in the solution of barium sulfate, okay? BaSO4, BPD/BaSO4. That palladium in solution of what now? Barium sulfate. That's what we call what? Linde's what? Catalyst. So this involves what? The direct transformation. It's a direct transformation of what? Of acyl chloride into what? An aldehyde using this what? Catalyst. All right, so you must take note of that. And it was named after what? Rosenmund. Okay, it was named after Wilhelm Rosenmund. Okay, it was named after William Rosenmund. Okay, because he was the first person to actually perform the experiment. Okay, the first person to actually do this. Okay, was what? Carl William Rosenmund. I think Carl Wilhelm Rosenmund. All right. So because he was the first person to do it, now take his name and what's named the reaction. All right. So please, you can try and form your own reaction, and if it becomes very useful to us, we'll give it your name. All right. So please start that for that. Let us see how this reaction goes. Let's see how this reaction goes. So this is an acyl chloride, Are COCl. Okay. So this and this, or you can write it like this: Are C double bonded to OCl. You can write it like this or like this. So that is what an acyl chloride. And we say it's what? A direct transformation. So it's a transformation. So we go directly. Okay, this is hydrogen, and then this is what? Palladium in what? Barium sulfate solution. All right, let me write this. Barium sulfate was solution. Okay, so this is what? Our Lindlar's catalyst, direct transformation into an aldehyde. So having an aldehyde directly, I'm going to have arrow CHO. Okay, so if, for example, our arrow here is what? Is a methyl group. Okay, let us see. So I'm going to have CH3 COCl, because it's a direct transformation, the same conditions, PD / BASO4. Okay, so what will they give to us here? To give us what? CH3CHO. Okay, so this can be either written like this, or you say CH3C double to OH, or you can draw the full structure like this. So this is our what? Our ethanol. This is our ethanol. All right, so that is that for that. So this is our acetyl chloride. This is called our acetyl chloride. Okay, so it's a direct transformation. So it's very easy. Okay, direct transformation of our acyl chloride into what? An ethanol using Lindlar's catalyst, or in the presence of Lindlar's catalyst. That's the second method we can use to prepare aldehydes. So let's forge ahead. Let's look at the third method we can use. This one is called Stevens reaction. Stevens reaction. This one is the conversion of a nitrile into an aldehyde. Stevens reaction. Okay, conversion of a nitride into the corresponding aldehyde. Okay, number 2, Stevens reaction. Okay, this one is what? Is conversion of a nitrile. We know what a nitrile is, right? Okay, having the cyanide group, compounds having the cyanide group that are called nitriles. Okay, so conversion of what? Of a nitrile, all right, into an aldehyde, into the corresponding, let us say the corresponding, into the corresponding aldehyde in the presence of what? Hydrochloric acid. Okay, so please, you must take note of that. So this one is Stevens reaction. Conversion of a nitrile into what? The corresponding aldehyde in the presence of what? Of hydrochloric acid. So let us see the reaction pathway. Okay, so firstly we have what? Our nitrile. So our arrow CN. Okay, so conversion, then plus what now? SnCl2. This one is called stannous chloride. Stannous chloride. Okay, then of course plus HCl. All right, take note of that. Then we now have what? The presence of hydrozonium ion. Hydrozonium ion. Okay, then this was our HCl, hydrochloric acid. Okay, this is what? Our conversion of what now? Of our nitride. This is our nitride. This is our nitride. All right, this is our stannous chloride. This is our hydrochloric acid. This is our hydrozonium ion. Then it gives us what now? Our aldehyde. So we are going to have what now? RCHO. Okay, so this is what? Our Stevens reaction, conversion of a nitrile into the corresponding aldehyde in the presence of hydrochloric acid. Okay, so this is our nitrile, this is our stannous chloride, hydrochloric acid, hydrozonium ion, and our what now? Our alkanal. Our what? Alkanal. Okay, so now if you want to, let's say this R group is a methyl group. Okay, if it's a methyl group, simple, you can write this reaction. In fact, you can pause this video and write out the reaction. Okay, so if it's a methyl group, I'm going to have CH3, okay, CN, right? Then plus what? SnCl2, then plus what? HCl. The same condition, H3O plus. Okay, so what is going to give us? It's going to give us the corresponding what now? The corresponding aldehyde. All right. So we're going to have our CH3CHO. Okay, so this is our what now? Our reaction what pathway. All right, this is our reaction what pathway. So you must take note of what of this. Okay, so this second method we can use to prepare what an aldehyde. So you can see here final what reaction we are what prepared what an alkanal, which is what ethanol there. All right, so now let us go to the third method now. I think the third method. All right, sorry, this is the fourth method. Okay, the first one was what oxidation of what or primary what alkanals. Second method was Rosenmund reaction. Third one is Steven reaction. So fourth method now. Let's go to the fourth method, and the fourth method is called Etard reaction. Etard reaction. Let us see Etard reaction. Number 4 now. Etard reaction. This Etard reaction is a direct oxidation reaction. This reaction is what? It's a direct oxidation reaction of an aromatic or heterocyclic bound methyl group into an aldehyde using chromyl chloride. Chromyl chloride. All right, so please you must take note of that. So Etard reaction is direct oxidation reaction of an aromatic. Remember when I talk about aromatic, I talk about what? The benzene what and benzene what derivatives. Okay, so it's a what? Direct oxidation, okay, of an aromatic or heterocyclic bound methyl group into an aldehyde using what? Chromyl chloride. So for example, if we have what a methyl group here, so this will make what will this be called? This either called what? A methyl benzene. Okay, but you know that a benzene ring having a methyl group is called toluene. All right, we remember that very vividly. Okay, so these are what our toluene. Okay, so we will say it's a direct oxidation. So direct oxidation in the presence of what now? Chromyl chloride. Remember, we're using what chromyl chloride as catalyst. So we must take note of that. So I'm going to have our chromyl chloride CrO2Cl2. These are chromyl chloride. Okay, and then of course, it's a direct oxidation. What does this give to us? This will give us what an aldehyde. So a benzene ring having what an aldehyde functional group is what it will now give us. So I'm going to have this. Okay, yeah. Now I'm going to have what CHO. What this one called? Remember, a benzene ring having an aldehyde functional group is called benzaldehyde. Okay, so this will be what our result. It's a direct oxidation. It's a direct what oxidation. All right. So please take note of this, and do not also forget that this also happens in the presence of hydrozonium ion. Okay, so this is our catalyst, chromyl chloride, in the presence of hydrozonium ion. It's a direct oxidation of what? Of a methyl bound aromatic ring, okay, into what? Into an aldehyde. It's a direct oxidation. So that is the fourth method we have considered. And then the last method now is called Gattermann-Koch reaction. Gattermann-Koch reaction. This class, okay, even when you get to the university in your 100 levels, they will be very useful. So some of you will even come back to this video while you're in 100 level to come and watch them. But no problem, because you are very much welcome. So do not forget to drop a like. Do not forget to drop a like. Do not forget to make sure everybody hears about what these classes. Okay, so let us look at the fifth reaction now. Number 5, we call it Gattermann-Koch reaction. And in this reaction, benzene is treated. Okay, let me just say in this reaction, benzene is treated with carbon monoxide. Is treated with carbon monoxide. Okay, with carbon monoxide in the presence of anhydrous aluminum chloride. Okay, so this is called Gattermann-Koch reaction. Okay, in this reaction, benzene ring, the benzene ring itself is treated with what? With carbon monoxide in the presence of what? Of anhydrous what? Aluminum what? Chloride. Okay, so it's a very, very simple reaction. It's called Gattermann-Koch reaction, where we treat benzene, okay, with what? Carbon monoxide. So tonight give us what? And what? An aldehyde. Okay, so let us see the reaction. Very easy, pretty straightforward, and what? One line. So we have what? Our benzene ring here. Okay, benzene ring, no attachment, no substituent, just a benzene ring. Okay, so it's being treated now. Okay, in the presence of what now? Treated with what? Carbon monoxide. Okay, hydrogen, and then here in the presence of what? Anhydrous. Let's say this meaning of anhydrous. Please take note. An dot. Also, I'm just putting to represent anhydrous because I do not want to write everything out. And anhydrous aluminum what? Chloride. Okay, to give us what? An aldehyde. So I'm going to have what? Our aldehyde. Okay, CHO. Okay, this one is also called what? Benzaldehyde. Okay, so please take note of what? Of all that. All right, so these are the methods we can use to prepare what? Alkanals. Okay, please make sure you just wrap your head around them. And the first one we talked about is very important. You may likely see it in your exam, so do not joke with it. So let us see the question from the O3 School JAMB app, and then we'll move further to talk about the next class. Now, this is a 2022 question we're looking at earlier. Alkanals can be prepared by oxidizing primary alkanols using what? Okay, they say acidified potassium, which is very wrong. We actually say you can oxidize them using what? Acidified, okay, KMNO4, or what? Acidified K2CR2O7. This is what? Acidified what? Potassium permanganate. Okay, or what? Acidified potassium dichromate 6. So our correct answer there will be what? Acidified KMNO4. No need to beat around the bush. All right. So now, okay, let me just leave this question for the next class because it relates to ketone somewhat. All right, so in the next class, we are going to look at preparation of ketone. So there are many questions on this application. Make sure you jump on the application, download it, and activate it. Do not waste your time. Preparation is the key. Start preparing early. My name is Master T, your Grand Commander. I'll see you in the next class. We'll talk about preparation of ketone. See you there.